Good evening, everyone. Can everyone hear me?
Yes, we can hear you.
Okay, that is perfect. So I would like to get the session started by saying a very warm welcome to everyone. This is our very first session for this Collaborate Online session, and it is meant to be a session that allows us to work through some questions so that you get more comfortable with the work that you have to deal with in the unit. And we will do this for each and every unit. And um, I will be posting in the student support forum, or you will see in the section that says online collaborate sessions on Moodle. I will be posting what questions I will be doing. So these are curated questions, so questions that we chose from um, the textbook. And these questions, I will just work through them and then maybe take questions from you as well, depending. So the purpose of looking at is to get you guys maybe to engage with the work regarding the questions that we have selected for you. And these questions are supposed to help you to answer your quizzes and your assignments as well. Most importantly, your assignments. So we have selected these questions in such a way that you will be able to engage with the work a little bit more better. So my name is Edward Chisoro, and I will be your teaching assistant for this module. I'm very delighted to have you in this module, as I will also be working with you in the next module, which is the B module. And we will discuss what happens in the B module a little bit later when we get to maybe unit 6 or 7. But this module will prepare you for what happens in the B module. But for the purposes of this module, we select questions every week for these collaborate sessions. So what we normally used to do was we would, the ground rules for the collaborate session are that if you have a question, may you please post it in the chat room. Normally I have your lecturer, Mr. Vian van Rienen, in the chat room as well. If he's available, he will help me to answer questions in the chat room. And then if he's not available, I will be answering those questions as well. And we normally ask that you post them in the chat room instead of unmuting yourself and then speaking, because we want to create a good flow of the session. And then I will also answer in the chat room, or Mr. Van Reenen will answer in the chat room. But I want to also do an experiment in terms of if I allow people to unmute themselves to ask a question, if that won't disrupt the entire session completely. So for today's session, I think I will allow for people to unmute themselves and then ask a question, but then we'll see how it goes. So I'm very delighted to be working on this module with you. As you might know, or you might not know this, the University of Johannesburg has moved from using Blackboard as their learner management system to using Moodle. So some of you might have experienced issues with the quizzes. These are being rectified and most of the issues have been sorted out. So you should be fine by now. But if you're not okay, please just do pop me or your lecturer an email and then we'll have a look at it. All right. So is everyone happy? Is everyone doing all right? You can also use the reactions. Okay, that is perfect. Okay. So the most important thing is that you can hear me properly, and I've gotten a couple of reactions, so that's good. And there's a text in the chat as well, so I appreciate that. What we'll be doing is looking at 5 sections, and I've selected 3 questions from each section from the textbook, and this gives us a total of 15 questions for us to have a look at. So before I jump into the questions, I'd just like to announce that these sessions are recorded for you to have a look at afterwards if you maybe after we've done the work. So I will then go into the work that we need to look at today. So we're going to look at section 0.1 through to 0.5. And please just bear in mind that my handwriting is not really this bad, but then with the tool that I'm using a pen, so um, it's hopefully you can read what I'm saying or what I'm writing. Okay, so we will start with section 0.1, and I encourage interactive sessions. So if I do ask a question, please do really feel free to give me an answer that you think is correct. So the first question is from section 0.1, and it's problem number 2. And it asks the question, determine the truth of the statement. So it's a true or false. And then it asks, if this statement is false, give the reason that why that is so. So only in the case that it is false, you must give a reason. Okay, so let's have a look at the statement that we're given at in this case now. So the statement says -2 over 7 is rational. Can I get an indication from either the chat room, or if you want to speak, if you can tell me whether this statement is true or false? Okay, I am just waiting. I see someone is typing. So the gist of it is this statement true or false? -2 over 7 is rational. Okay, so can we just give a true or false answer in the chat room? True. Okay, so we have one answer in the chat room that says it is true. And depending on whether everyone agrees with that statement, we're going to have a discussion about it now. So the question is pivoting on this important statement that says rational. So rational means that you have an integer divided by another integer. And then we need to just go and analyze what is happening. -2 is an integer, and 7 also is an integer. So this statement is definitely true. All right, so we'll have a look at the solution now. And it says true. So thank you. Is it Vern or Vinay? Apologies. I do struggle with languages sometimes. Numbers, not so much, but languages I do struggle with. So it's Vern or Vinay. All right. Okay, second pronunciation. Thank you. I think it looks like I did mute everyone from speaking, so I will just change the settings just so that people are able to speak in the meeting if you do want to speak. And then I will see how well this works because normally we just allow the chat room only. So I want to just experiment with this and see how well it works. All right, so I have allowed you to unmute yourself. Let's see how that works. Okay, so let's move on to the next problem, which is problem number 10 of section 0.1. So this is asking us determine the truth of the statement. So much like the previous problem, and then it says if the statement is false, give a reason why that is so. So the statement says pi is a positive integer, right? So I'm sure you all know what pi is, or maybe some of you have heard about this number pi. The statement says pi is a positive integer, and then the question says, is this true or false? So may I please get an indication from either the chat room or you can try and unmute yourself and tell me if this is true or false. Is pi a positive integer? Yes, thank you for unmuting yourself, Nontokozo. I see you've just joined, so I'm not sure just how far you see where we are. All right. Is there anyone with a response before I move on to the solution? All right. Okay, so I see someone is typing, so I'm just going to allow them an opportunity to respond, but then we need to ask ourselves, it is not positive. All right. So false, I think. Okay. Thank you, Annie and Elizabeth. Um, Please do forgive me if I do pronounce your name incorrectly. I did give a disclaimer that I'm not an expert at languages, but you are both correct. So pi is not a positive integer. So where it goes wrong is actually in terms of integers. So pi is actually positive, but it is not an integer, right? So pi is an approximation of the circumference divided by the radius. So approximately, let's see, it is approximately 22/7, but then even this is not an integer, right? So we know now that this is false. Pi is an irrational number. Okay, so what I'm going to do now is that I'm going to, if we get a similar kind of question, I'm going to continue on to the solution. And then when we get to a new concept, I'm going to also open up for discussion. So now still in section 0.1, we have a true or false, and it's asking us, is square root of -1 a real number? Okay, so if we have a look at square root of -1, okay, we notice that any square root of negative numbers is called imaginary numbers. So this is exactly the opposite of what a real number is. So the answer would be false. Minus square root of 1 is not a real number. All right. So we give the answer as false, and they say give a reason why that is so. and we say it's not a real number. And then we move on to section 0.2 now. Okay, so here again, I will give an opportunity for people to engage. In section 0.2, we start dealing with some properties of real numbers. And the first question is asking us to determine the truth of the statement. Once again, it's a true or false question. And it gives us a left-hand side of the equation saying x plus 2 in brackets multiplied by 4 is equal to 4x plus 8. So if I can get in the chat room, or if you can unmute yourself and just say what you think, is this true or false? And remember, if it is false, we need to give a reason. So first of all, let's just decide, is it true or false? What do you think? Okay, I don't see anyone typing. So I'm going to go through the question in mathematically as we would normally. So if we have two brackets that are multiplying themselves, you notice that the first bracket needs to multiply the second bracket. So when we do that, the first bracket is a binomial, which means there are two terms. This must multiply that first term, and then we do plus this must multiply that as well. So if we do the first term, x times 4 is 4x plus, which is the sign that is there. Then we go 2 times 4, it is 8. So this left-hand side, so the left-hand side is actually equal to the right-hand side. So if we are to determine the truth of the statement, we would then say what you are now saying in the chat room. Apologies if I'm not giving you enough time. It's just that we have an hour and I would like to go through all the problems. So sometimes I might get impatient and then go through the solution, but it is indeed, as you say in the chat room, true. All right. So this is indeed true. And remember, if you have any question, you are please feel free to ask your question. And I am keeping my eye on the chat room as I'm looking at the problems as well. So indeed, the solution is true. So we can tick that as true. And then the next question is asking us from the same section. We are now looking at problem number 20. State which properties of real numbers are being used. And in this case, I would really like to give you guys a chance to tell me what you think the properties of real numbers, which property of real numbers is being used, or which properties, right? So if we're given -1 in brackets multiplied by -3 plus 4 in brackets equal to, and then on the right hand side of the equation, we have -1 in brackets multiplied by -3 in brackets plus -1 in brackets multiplied by 4 in brackets. Which property of real numbers is being used? Please let me know in the chat room what you think, which property is being used. You are welcome. Maybe you can't unmute yourself, or I've tried to change the settings of the meeting so that you can unmute yourself to make it easier instead of typing. But if you can type quickly as well, please do let me know which property of real numbers is being used. All right, just waiting for anyone to. Okay, allow mic, allow camera. All right. Looks like we might not. Okay, so we do have one person typing, two people typing. Okay, so that's promising. I do always encourage engagement. Um, in the many years of tutoring and teaching that I've worked, I found that if you do participate, you learn more than if you don't. Okay, right. So rational numbers, both positive and negative integers. Okay, thank you for the input. I can see that we do have rational numbers, both positive and negative. But then now the question is, which property are we using to actually go from left-hand side to right-hand side with those rational numbers that are both positive and negative? All right. Thanks, Nontokozo. Identity. Okay, so it is almost the identity property, but not quite. So what is happening is we are going from left-hand side to right-hand side. So what happens is that if we have one bracket multiplying another bracket, and if the result on the right-hand side was just the answer, right? If it was -1 times -3 plus 4, and then we work it out and we write the complete answer, it would definitely be identity property. But in this case, it is expanded to say it's -1 times -3, then plus -1 times 4. So this is a different identity that is, or different property that is used, and it is called the distributive property. So you distribute the multiplication across both brackets. So -1 times the first term, which is -3, plus -1 times the second term, which is 4. So this is definitely distributive. Okay, so let's just have a look at the solution. Okay, indeed, it is distribution. So I know the textbook lists the distributive. I know the textbook lists the properties in terms of numbers, but if you are to answer an assignment or and answer any question that is asking which property, you need to state the name of the property because a different textbook might list these properties in a different order. All right, so that's just important to note that. Right, thank you very much for engaging. Now, if we go to the next problem, I'm just going to speed up the pace a little bit just so that we stay on time. The next problem is asking us to simplify the following if possible, and then we are given an expression. All right, so this is still sections 0.2, problem number 40, and we are asked to simplify minus and then bracket -6 plus x, right? So I'm actually going to use the distributive or distributive property, depending on how you want to pronounce it. I did give a disclaimer that my pronunciation and my language is not really firsthand, so please bear in mind with me. So I'm going to use the distributive property. We have a minus. This just means -1 times this bracket. This bracket has two terms, so we're going to multiply this minus into that term plus multiply this minus into that term. So this will give us minus multiplied by -6 plus minus multiplied by x. And if we know minus times minus gives us a positive, and then we have 6, and we don't need to write a plus if the thing is positive, and then plus times minus gives us a minus, and then we have x. So our answer should be 6 minus x, Thank you very much, Vinay. So we get 6 minus x. Let's have a look at our solution. 6 minus x. Perfect. Now, if we go to um, section 0.3 now, which is the next section that's looking at exponents and radicals, so slightly chunkier or more interesting maths, if we'd like to call it that. Um, we are asked to simplify and express our answers in terms of positive exponents. So we want to follow the instruction. So the instruction says positive exponents, right? So we need to first of all simplify, and then we express our answer in terms of positive exponents. So we just use the rules of exponents and radicals. In this case, only the rules of exponents. If you have a look at it before we even jump into the question, we have the same base, x, x, x. So what we would do first is we would ideally simplify the numerator, and then after that, simplify the denominator, and then after that, simplify the whole expression. So in the numerator, we have x to the power of 2 to the power of 3, and we know that becomes x to the power of 2 times 3, right? If you raise something to a power and then raise it to another power, you need to multiply the powers. Now, that then is the same for x to the power of 3 to the power of 2, so that it becomes 3 times 2. So we'll come back to now, if you multiply two things with the same base that have the different powers, then you need to add the powers. These are just rules of exponents. So in the denominator, we have the same case as we had in the numerator, x to the power 3 to the power 4. So you need to multiply the exponents. And if we simplify this before we get to the end, we get x to the power of 6. So 2 times 3 is 6, and then multiplied by x to the power of 3 times 2, which is also 6. This is divided by x to the power of 3 times 4, which is 12. Now we have two bases which are the same and are being multiplied. So we need to add the exponents. So this would be x to the power of 6 plus 6, which is 12, over x to the power of 12. You can either use the exponent rule that says when there's a division line, you minus the exponents, much like when there is a multiplication, you added the exponents, right? So 6 plus 6 gave us 12. When there's a division line, you just subtract. So if we use the division line rule, it will become x to the power of 12 minus 12. So I'll write 12 minus 12, which is x to the power of 0. And anything to the power of 0 is equal to 1. You can check that on your calculator. If you try, you can do 5 to the power of 0, minus 10 to the power of 0. You will find that it is equal to 1. Or you can say something divided by something. If the something is the same, the answer is equal to 1. So if we divide one pizza according to one person, you will have the whole pizza, right? So that is the rule that we're going to use, and we'll check the solution, and indeed our answer is 1. All right. So just keep in mind that I will share all these worked out solutions with you in the support forum after the session, every time that we do a session like this. All right. So now continuing to the next problem in section 0.3, which is problem number 35, we are now asking for simplification of the expression. So we're not asking to solve any equation. We just want to simplify the expression. So what we have here, if we review, is what we call surds. Right, so we have 2 root 8 minus 5 root 27 plus cube root of 128. So if we look here, there can be some ways to simplify square root of 8. Okay, so a square root is like the second degree of the root. So this would be equal to 2 times square root. What numbers can we use to make up 8 that have something that if you find the square root of, you'd find a simpler version? I know this is maybe reaching, but I'm asking the chat room. What two numbers can you multiply that if you find the square root of one of them, it would simplify this expression for us to get 8? So how can we simplify a square root of 8? This is assuming we're not using a calculator. So 8 can be written as what two numbers multiplied by each other? Two and 4. That is perfect, right? So 2 and 4, and we are going to say 2 times 4, because we can find square root of 4, which is 2, and that will allow us to simplify. So let's go on, and here we'll see that we would have reached our end because we can't simplify square root of 2, so we would have actually answered that question for that first term. So the next term is minus 5 times, let's do the same exercise for 27. What numbers can you multiply 27 with that will simplify 27 under the square root? So it could be two numbers. What two numbers can you? 9 and 3. All right, people on fire. Okay, well done. So that would be 3 times 9, and then plus, let's do the same thing with cube root of 128. What numbers can we use to find 128 to simplify cube root of 128? Remember now, it's not a square root, it's a cube root. So we're looking for a number that you can find a cube root of that we can simplify 128. I know this is a slightly trickier one, but please have a jab at it. You can do some trial and error as well. You can say 128 is, if you try 2, it would be what, 64. If you try, yeah, try a couple of numbers. No takers. All right. Okay, so I'm going to jump into this one. So the ones that I actually suggested are 2 and 64, and I picked this 4 by 32. So the only problem with 128 being 4 times 32 is we can't get a cube root of 4 and we can't get a cube root of 34. Hence, we can't simplify that. But if you have a look with what we've done now, 2 and 64, 64 is actually a cube of something. So it allows us to actually simplify that a little bit further. So let's investigate further. So this would be, maybe let me just show the solution since it's the next line. You will see that this one is exactly what we wrote, 4 times 2 or 2 times 4. And this one is 9 times 3 or 3 times 9. And this one is 2 times 64 or 64 times 2. The reason we chose these is that if you do square root of 4, you get 2, right? So that simplifies that. Square root of 9 is 3, and then cube root of 64 is 4, right? So 4 times 4 times 4 is 64, right? So this one was a cube root. So what number do you multiply by itself 3 times to get this number that we're choosing, and it is 4. So now in the end, we will have something with a square root of 2, a square root of 2, and a square root of so this is actually a cube root of 2 and then a square root of 3. So the first one would be 2 times 2, which is 4 root 2. Second one would be 5 times 3, so minus 15 root 3. The last one would be 4 cube root 2. And we can't simplify this any further because square root of 2 is a decimal, square root of 3 is also a decimal, cube root of 2 is also a decimal. So we can't go any further and we can't add any of these items together because this one says something with a 2, this one says something with a 2, but this is a square root. So the number here would actually be a 2 and the number here is a 3. So we can't add these two together. So this is now the simplified version. This is the final answer. Right. If we move on to the next problem, which is problem number 52 of section 0.3, it is asking us to write the expression in terms of positive exponents only, right? And then they say avoid all radicals in the final form. For example, if we have y to the power of minus 1 times square root of x, we must write it as x to the power of half over y. So this is what we call a radical because a square root, it's under a radical sign. So this is a radical, and then this is a negative exponent. So we want only positive exponents. So we need to go and approach our question and answer it in that form. Right. So if we have a look at what we're given, we are given this thing here. So we have a radical. Firstly, we have a radical. So we need to get rid of that radical. And you see the radicand there is, or the index is 4. So it means whatever is underneath this radical sign is to the power of a fractional power over 4. So 1 over 4. So we have a to the minus 3, b to the minus 2 to the power of 1 over 4. Does everyone understand this? So we've just rewritten this part, just this part. Can you please show a thumbs up or if you understand, or a thumbs down if you don't understand? Or you can also chat. That's fine. Thumbs up. Okay. If you are feeling lost, please don't feel discouraged because I'm always available to answer your questions. If at any point I lost you, please do feel free to email me. I'm happy to engage with you on a one-on-one basis to just chat about where you didn't understand or where you got lost. Okay, so a couple of thumbs up. Thank you very much. So that was the first part, right? Okay, so Nuntoko, so you can just text me where you got lost. But if it's still too far out, it's okay. Please still do engage with the session. And then maybe when you can review the session, you can tell me exactly where you got lost, and I'm happy to help you through that. Right. So the first thing is we've rewritten this radical in terms of exponents, and then we need to do, this is a multiplication, okay? So this is multiplied by a to the power of 5 times b to the power of minus 4. Now we need to have a look at the bases. So we need to look at the common bases. A, there's an A there, and then there's a B there, and then there's a B there, right? So if you multiply two bases with different powers, you need to add the powers. So this would be a to the power of minus 3 plus 5, right? And this would be times b to the power of minus 2 minus 4. But then Now I'm making the mistake of forgetting this 1/4, right? So we first need to simplify this. We need to simplify this. This is minus 3 over 4. If you have something to the power and then you raise it to another power, you need to multiply the powers. Okay, so apologies for that. I'm getting ahead of myself. Let's go and do it step by step. So this is the step that we just did. Now, this bracket, we have something to a power raised to another power. When that happens, you need to multiply the powers. So minus 3 times 1/4. If you put that in your calculator, it will give you minus 3/4. Okay, here it is. And then minus 2 times 1/4. If you do that in your calculator, it will give you minus half. Right? This one stays the same because there's nothing, we are not multiplying this to any power. So it stays the same. And then the next thing that we do is we have the same base. So here the same base, same base. So we need to add these exponents. So minus 3/4 plus 5. Here we go. And then minus half plus minus 4. Here we go. Right? And then we just do the calculation. I know minus 3/4 plus 5 is 17 over 4. And then minus half minus 4 is minus 9 over 2. But the instruction said only positive exponents. This one is not a positive exponent. It's negative. So we're going to need to put it in the denominator. So that would be, if you put in the denominator, it'll become positive. Therefore, it'll be b to the power of 9 over 2. And here we do not have any radicals as well. If you were to write this in terms of radicals, this would actually be a to the power of 17. Sorry, 17. And then that's the fourth root. That's a radical. And then that would be b to the power of 9. And that's a square root. And I don't read tonight, write that 2. But the question said no radicals. So we need to stop at this point. Okay. Okay. All right. So I see we've got about 15 minutes left. So I'm going to try and get through the next questions a little bit faster. Apologies for that. I tend to try and over-explain myself. Right. So the next question says, perform the indicated operations and simplify. So here we see 2 brackets and we have plus. So when they say indicated operations, we just need to check what operations are happening. In this case, it's just addition. So we need to plus these things. When you have brackets, what's happening inside the brackets? Here it's addition and there it's addition. So we can add things, right? So the first thing that we do is we need to add the things in these brackets. So square root of x plus 2 square root of x. Think of square root of x as an apple. If you have 1 apple plus 2 apples, you must get 3 apples, right? And then we have a plus. So we go plus. And then 3 apples plus 4 apples must give us 7 apples. So now we have 3 apples plus 7 apples. That's definitely 10 apples. 10 square root of x. So that one was a simple one because everything was square root of x. Everything was similar, right? That's why I kept saying apples. All right. So we performed the indicated operations. This was just addition. Okay. Now, if we have a look at the next one, it says perform the indicated operations and simplify. Now we've got slightly more interesting stuff, right? So we don't just have apples because it's t squared minus 5t, and then it's 3t squared minus 7t, and there's a multiplication happening there, right? So here, if we have a bracket and then next to it another bracket, this is multiplication. So we need to multiply. That's just it. It's just they're saying multiply this out. So you need to use I think previously some people might know what is called FOIL. So you need to use the FOIL method. The first term multiplied by the outer term, and then these two terms, and then those. Oh, I've done that already. And then these two terms, and then those two terms, right? First, outer, inner, and then last, right? So if we do that, we're going to have t squared multiplied by 3t squared. So this is the one that we're doing. And then we get t squared multiplied by minus 7t, which is that one. And then minus 5t multiplied by 3t squared, which is that one. And then minus 5t multiplied by minus 7t, which is that one. And then we just simplify, right? So you can have a look at that. So t squared by 3t squared is 3t to the 4. T squared times minus 7t is minus 7t cubed. Minus 5t times 3t squared is minus 15t cubed plus 35t squared, which is the last two terms. And you look at similar terms. This is t cubed, that's t cubed, so you can add them. Minus 7 minus 15 gives us minus 22 t cubed. And then the first term has no like term, the last term has no like term. So this last term is actually the simplifying stage. All right. Now, if we go to, um, okay, I see that comment came a while ago saying that was a lot, but we can chat about it and you can tell me where maybe you want to engage, but thank you for engaging. Section 0.4 now. Second question is problem number 48, which is actually also asking us to perform the indicator operations and simplify. So here we see we have a fraction and we have some stuff in the numerator and something in the denominator. Fortunately, the denominator only has one term. So most of the work is only actually going to happen in the numerator. So we need to do this subtraction and then this subtraction as well and this addition. So you will see that for the first subtraction, there are no like terms, so we can't simplify. For the second addition, there are no like terms, so we can't simplify. So we need to do this subtraction. Bear in mind that if you do a minus with brackets, this minus multiplies that and it multiplies that. So let's expand that. So it's 3y minus 4 minus 9y minus 5, which is exactly what we have there. And then now we have like terms, 3y and 9y. So 3y minus 9y is minus 6y. And then minus 4 minus 5 is minus 9. Now, if we simplify, we have a denominator, divide each term by the denominator, and then we get minus 6y over 3y. The minus 6 and the 3 cancel to give us a minus 2, and then the y and the y cancel to give us a 1. So minus 2 times 1 is minus 2. And then minus 9 and the 3 cancel to give us a minus 3. And then we're still dividing by the y. So that's minus 3 over 1. And that will be our final result. Right. Now we move on to, problem number 8 of the next section, which is section 0.5. And now in section 0.5, we're looking at factoring, right? Some of my favorite problems are about factoring. The first question is saying factor the following expression completely. And we're given a quadratic expression. Okay, so I don't know normally how you do it, but then in high school when I did it, it was multiply this term and that term, and then you'll find that this is minus 6 x squared Or if you just multiply the coefficients, let me do that, minus 6, and then you take the coefficient of the middle term, which is minus 1, and then you do a thing. So find two numbers that if you multiply, they will give you this one. So if you multiply, they'll give you this one. If you add, they will give you this one. So if I multiply 3 and minus 2, they give me minus 6. But if I add them, they give me 1. So I will now try minus 3 and 2. They will give me minus 6. And if I add them, they'll give me minus 1. Therefore, I know my factors are going to be x plus 2 and then x minus 3. Right? So that's the plus 2. That's the minus 3. Okay, so there's various ways of doing this. And I can't really go into the gist of where the methods come from, but I know your calculators also can do the same thing. There we go, x plus 2, x minus 3. Right, and we need to factor this as well. And we need to be in the business of noticing certain patterns. So the pattern here is that I noticed that it's not two brackets, so it's two terms. I see there's a 4 and there's something that is squared. Here there's 9 and something that is squared. So there's squares here and there's a minus. So this is a difference of two squares, right? So some people call it dots or DOTS, difference of two squares. So this would just be the square root of this. So square root of 4 is 2, square root of t squared is t, and then square root of that is 3, square root of that is s. So these would be our two brackets. And then you just do plus, minus. Okay, if you actually work this out, you will find you will get back to that. That's a difference of two squares. All right, so 2t plus 3s times 2t minus 3s. So it doesn't matter if you interchange these brackets, okay? All right, second last problem. Sorry, I'm just rushing a bit because I don't want to go over time, because I also have the B module happening exactly at 8. So I'm going to log into that straight after this session. So I want to get to the last problem to also chat to you if you have any issues. So you can let me know for future engagement. So factor the following expression completely. This one is problem number 42 of section 0.5. Here, if we have a look, okay, we don't really have like squared terms. We have a couple of terms here, but then we'll notice that this is probably like a common factor problem, right? Common factor. So what we'll then do is we check, this is a plus 5, it's occurring here, and then there's a plus 5 there, a plus 1 is there, maybe I must do that, and then there's a plus 1 there as well. So we take the highest common factor, so the highest common factor, and then we factorize. So in the first term, this is cubed. In the second term, it's squared. So the highest, actually, we take the lowest common factor, sorry. Lowest common factor. The lowest one is 2. So a plus 5 is squared. And then there it's a plus 1 squared. There it's a plus 1 cubed. So we're going to take the lowest one, which is 2. We just factor it out of the first term and the second term. So if you take 2 of these first ones out, you'll be left with 1. So that's one of them. And if you take 2 of them out from the first one, you'll be left with nothing. So I didn't write anything there. Then we go plus. If we take 2 out, we'll be left with nothing. So I didn't put anything with a plus 5. And then if we take 2 of them from there, we'll be left with a plus 1. That's why this is to the power of 1, right? Same as that. And then if we then simplify, because it says factor it completely, so we need to simplify. this would be a plus 5 plus a plus 1. So this would be 2a. So a plus a, and then 5 plus 1, 2a plus 6, right? If we were doing factorization, 2a plus 6 actually factors out to 2a plus 3. And then this would be actually the end of your problem, but then we normally like to write numerical answers right at the front and then algebraic ones at the end. All right. Now, this is the last problem that I wanted us to have a look at. Apologies for rushing through it, but then could you please let me know either via email or now if you guys are okay, and um, if it's something that you want to discuss, you can do it via email. But otherwise, I hope you guys had a productive session. Did someone at least learn something?
Hi, can you hear me?
I can most definitely hear you.
So I think it was a really good session and there was some stuff I learned. I think this last problem that we just did for me was like a lot. So
Yeah,
factoring is like, yo.
yeah.
So I think I'm definitely gonna need a little bit more time on that. But generally, I think the session was very informative and quite helpful. So thank you for that.
Thank you very much for the feedback, Elizabeth. Just always feel free to drop me an email. It can be an email, or you can use the support forum, but I normally see my emails a little bit more than the support forum because I have specific times that I check the support forum. So just pop me an email if you're struggling with anything, working on something, and then I can just engage with you on that. I'm more than happy to do that. I know the last couple of minutes were rushed. It's because I wanted to start slow, but now at the expense of the last couple of questions. But thank you so much for the feedback.